The derivative at a point on a curve is the slope of the tangent line at that point with these pictures. Let's start with slope again. Reminders, slope, if I have 2 points, a straight line passing through the 2 points, then the delta y over delta x measures the slope. And it measures the steepness of the line. So if the line is horizontal, slope is 0. As it gets steeper, the slope gets bigger. For a curve, then we have different slope. It goes up and down. So on these pictures, we can use the tangent line, slope of tangent line as the slope of curve. And then we can see that at the point P, the slope is positive. And at point Q, the slope should be negative, and at the point R, the slope horizontal is 0. And reminder that places there are points where on curve that slope doesn't exist. Over here, we really don't have a tangent line. Over here, the tangent line is vertical, so it doesn't have a slope. So we might not have slope. The derivative is another name for the slope at a point. And the slope at a point, we use that to define the steepness at that point. And here's how we calculate it from this example from previous sections. Here's the pictures. We start out with at a base point 2, and we deviate by h, which is 0.2. So basically, we have 2 points from here to 2.2 over here. We connect a line, and we want to calculate the slope of these points, and use the difference quotient or the slope formulas, and we can calculate the slope of these connections of this chord is 2.2. Now, I'm going to let in this example, instead of using the 0.2 over here, I'm going to let this h float as a variables, then go through the same calculation of a quotient, difference quotients, and simplify it, and simplify these expressions. Then this is the algebra that we find out. Oh, the slope connecting the points 2 to here is 2 plus h. Now, we can from here deduce what must be the slope at the point base point 2. How? Because we can say let h become smaller and smaller, and we can take the slope at the point 2 by taking this point h, or this point getting closer and closer, so the line gets the line gets closer and closer, and then that's as h goes to 0, then this tangent line must have slope 2 because h is equal to 0. Okay, and then we can calculate in general that I can calculate this formula if I let x inside at the base point 2, can let x as a variable too, so, and then simplify the difference quotients. If I connect a point from the generic x to its neighbor x plus h, for this formula, I can calculate, remember from previous example, what the difference quotient simplify down to these. And then as h go to 0, then this line become closer and closer to the tangent line. So it links toward the tangent line. So the tangent line must has slope equal to 2x minus 2, depending on what the number x is. So this basically, this formula 2x minus 2 is called the derivatives of the functions x squared minus 2x plus 2. It calculates the slope at a point at x for the function y equal to f of x. For example, at point 3, at x equal to 3, the point 3,5, to calculate how steep it is, you plug the 3 into the slope formulas or into the derivative, so I get 4. Therefore, the steepness of at the point 3 to this graph is 4. Okay, and that's what the derivative is. Bye-bye.